and there will be very less human intervention. It means there will not be an intervention from the human being side. It means all these devices will be able to perform all these tasks automatically. It is one of the fastest developing fields in the field of history of computing. Let me check whether it is okay. It is one of the fastest developing field in the history of computing, and almost 50 billion devices by the end of 2021 are expected. So implementing security. So this is the basic idea of IoT. Now we need to understand why security is very important in case of IoT, since we are going to discuss more and more on security concern. Okay, so it is one of implementing security measures such as encryption, authentications, access control, network and application security. Those are being used in various standards such as TCP, IP, and other wireless type of standards. Those will not be sufficient for IoT devices, right? So as you can see, all these the current security mechanisms that we are using are going to be ineffective in case of IoT, because we will be able to connect billions of devices, and all these devices are supposed to be secured from any unauthorized access. Moreover, the cross-cutting and the large-scale nature of IoT systems with various components involved in the deployment of such systems have introduced new security challenges. So nowadays, as you can see, you may see like lot of work is going on, and a lot of like security breach are going is happening, right? So due to which we have to come up with some new idea in order to secure our system. Therefore, existing security methods should be enhanced to effectively secure the IoT ecosystem. So the main target is we need to perform number of schemes, or we need to provide some some good and what validated security mechanism, so that our IoT ecosystem can be secured, okay, from any authorized access. So AI methods are important in transforming the security of IoT systems from merely facilitating secure communication between devices to security-based intelligence system. So nowadays there is a possibility where we can use the idea of ML and AI to integrate with some existing security mechanism in order to secure our system from any upcoming challenges. So AI and ML can still play a very critical role to provide security with our existing IoT systems. So the goal of this presentation is to discuss basics of security and privacy issues in IoT and their solutions. So we will be mainly focusing on what kind of security and privacy issues we need to face in IoT systems, and what can be the possible solution related to that can be used to develop enhanced security methods for IoT systems. So let's conclude from here. So before this, I will again give you the brief idea of IoT. I know like you might have seen the basic understanding of IoT many times, but let me discuss this again very briefly. Okay, so as you can see, the device should have the following components for them to properly operate as part of their respective IoT system. So these are the important equipments, are important parts, components. Those will be able to establish our IoT system. The first one is sensors, and at the beginning we need to start collecting data from the environment for the IoT system. So the collected data by the sensor that can measure occurrences or changes in the environment. So we will be using some specific type of sensor, right, that will be very specific to our requirement. So what kind of data or what kind of information we want to collect from the environment. So if I want to know the temperature, we will be using temperature sensor. If I want to check the humidity, we will be using that type of sensor. So depending on the requirement, we can use different type of sensors, right? So the kind of data being measured by the device depend on its functions, right? So it can't be a pulse in the case of fitness tracker, and distance of the nearest object in that of an autonomous vehicle. So number of sensors can be used nowadays. Also the type of sensors we can use are very advanced, and they will be able to collect very advanced type of information that can be used further for other purposes. Okay, so it can also be used for some other research of areas. Okay, then connection and identification. So the data must be communicated from the device to the rest of the IoT system, right? So for which what we can do, a device must have a unique identifiable presence of the internet. So in that case, what we can do, we can provide a specific or unique IP address to all connected devices, so that all these devices can be uniquely identified within the system, right? And there will not be any ambiguity with that. Then actuator. So most IoT devices are capable of doing their primary functions without physical interaction with their users. So in that case, as you can see, there will not be any human intervention with the IoT system. So IoT devices should be able to take actions based on data from their sensors and subsequent feedback from the network. So what we can do, depending on the data collected and depending on the task, some processing can be done, right? So depending on the situation, this IoT system will be able to make some action. Suppose if I say, if I'm going to design a smart light bulb, and if I'm going to equip a IoT system for a smart home, so what we can do, we can place a smart light bulb, and depending on the what are the movement, it will be able to switch it on or switch it off, right? So it will be able to perform all such functionalities automatically. Now IoT gateway. So IoT gateway is another device component that can connect our IoT system with the rest of the what cloud. Okay, so the IoT gateway acts as a bridge for the different devices data to reach the cloud. So this is the way we can connect our IoT system with the cloud, right? So IoT gateway is another important component to connect our IoT system with the cloud, where data can be sent for further computation, right? The second last component is cloud. The cloud is where all data from the different devices is gathered and where software can read this data for processing. So whenever the data is collected, depending on the collected data, we will be able to perform some processing thing. So the cloud will be responsible for performing all such processing related to the collected data. Okay, after which there is still a possibility of user interface. The user interface communicates to the user and data gathered by the devices and allows the user to make the necessary command to be executed by the devices. So in that case, what happens? Depending on the requirement, there might be some possibility user can give some specific command to perform some specific execution, right? So user interaction is still possible because we always have some administration control with the existing IoT system, right, to perform some specific tasks that can be given by the developer or the end user. Okay, now, so the number of technologies have made IoT possible. The first one is access to low cost, low power sensor technology, right? So these are number of technologies those have really made IoT possible. So if any such possibilities are not there, it could have been very difficult to achieve all such possibility of IoT. Okay, so access to low cost, low power sensor technology. So affordable and reliable sensors are making IoT technology possible for more manufacturers. So nowadays the cost of each and every sensor are very low, and they will be able to perform number of tasks within the same device. So if since the cost has become very low, right? So number of sensors, number of IoT devices can be deployed within the same target region, right? The connectivity. A host of network protocol for internet has made it easy to connect sensors to the cloud and other things for efficient data transfer. So nowadays we are using some standards in wireless network so that all these data can be able to reach the cloud, right, without consuming much more very so much of energy, right? And also at the same time we will be able to achieve better bandwidth, right, in order to utilize the given bandwidth in a better way, right? So we have come up with number of standards or technologies so through which we will be able to send or transmit all this data to cloud for further processing. Okay, then cloud computing platforms. So this is another the same component that is mainly responsible for perform some processing kind of task for all collected data, right? So depending on the collected data and depending on the requirement and depending on the scheme, we will be able to perform some specific task. Okay, machine learning and analytics. So with advances in machine learning and analytics, along with access to varied and vast amount of data stored in the cloud, business and can gather insight faster and more easily. So nowadays we don't really need to worry what is the size of the data and how large is it. So number of machine learning and analytics technique can be used to perform some specific task for any number of data. So we can use the idea of data science, we can use the idea of data mining, we can use the idea of another technologies to work on all these collected data. So there is a possibility where number of like schemes can be applied to all gather data, right, in order to perform some specific tasks. Okay, the next thing is conversational artificial intelligence. The advances in neural networks have brought NLP to IoT system, such as digital personal assistants Alexa. So you know about Alexa, Cortana, and Siri, right? So all these like smart devices or personal assistants are based on NLP, right? So what we can do, we can make some specific user command to for some specific kind of service, right? So nowadays, as you can see, number of technologies and number of ideas are available, right, through which we will be able to get a special type of services, or through which we will be able to provide number of services to their end users. Okay, in the IoT ecosystem. So as you can see, each and every devices will be the IoT system will be having number of components, right? So there will be battery, right? So battery is always there, right? So and this is a unit. So this is the unit along with each and every devices. So as you can see, it will be having sensing element, processing element, and communication element. So sensing element is mainly used for sensing environmental condition, right, from the target region, after which it will fed to the it will be sent to the processing unit. So there might be some possibility where we want to filter our collected data before forwarding to the cloud. So there is a possibility where we can perform some pre-processing type kind of task, or we can perform some other tasks, right, before transmitting all this data to cloud. Okay, so we can filter some important data from the collected data. Those are really required to be sent further. Okay, after which there will be unit communication unit, right? So it could be either wired or wireless. But in case of IoT, most of the cases it is going to be wireless unit, right? And they will be equipped with some transmitter, so they will be able to reach some distance, right, for transmission of data. Okay, and after which there will be application tools or API. So it will be designed by the developer or some end party. After which there will be gateway. So this is the component that will be connecting this IoT system with the rest of the cloud, right? So through this gateway, we will be allowed to send all these data to the cloud for further processing. Okay, and as you can see, there will be some external device equipped with this IoT device. So as you can see, this is nothing but battery. So there is a possibility either this battery can be rechargeable or replaceable. So it should be placed in such a way it can be rechargeable or replaceable whenever there is a situation. So because if the battery is died and if it is not rechargeable, right, the entire device will be dead. So there is a possibility, right? It totally depends on the requirement. If the cost of this device is more, we will always try to replace or recharge the battery. Okay, and as you can see, the battery the battery is very important. The energy consumption is also very important in IoT system. So in that case, what happens, in order to conserve the energy of the battery, right, we need to perform all these tasks in a very efficient way. So number of schemes will be used to perform the same task with very less battery consumption, right? So the battery consumption will always be a very critical challenge in IoT system, right? Because if I'm not very careful at the time of processing, and if I'm not able to use the available resources in a better way, the battery will die very soon. So but in case of IoT system, the lifetime of the network should always be extended as much as possible, due to which all these units should be able to consider some schemes or technologies or techniques so that the battery can be expanded as much as possible. Okay, let's go ahead. Moving on, so this diagram shows the architecture of IoT. Okay, so as shown in the figure, IoT structure can generally be divided into three distinct layers. The first one is the physical layer, the perceptron layer, right? Network layer and application layer, right? So sometimes perceptron layer is also referred as a recognition layer, right? So it can be either referred as perceptron or recognition layer, and you can use different terminologies for the same IoT standard, right? So let's discuss the basic functionality of these layers. So the perceptron layer is mainly responsible for gathering all kind of data from the physical world using physical end devices. So again, we will be using sensors to collect any physical related information, right? So we can use either RFID tags, cameras, GPS, receivers, right, and all sort of sensors. So depending on the data, we can equip different type of sensors along with the data, right? So we can equip the device with camera if I want to collect some visual data. We can, if I want to get the location of the system, we can equip with GPS, right? If you want to get get the temperature, we can use temperature sensor, right? So this is how, depending on the requirement, different type of sensors can be there. Then the network layer, which is in the middle, consists of different type of communication networks, service access network. So as you can see, the number of standards we can use, right, as a part of network layer. So these are nothing but the protocol. Those are mainly responsible for achieving end-to-end data transmission, right? So these are some important standards that can actually be used for achieving wireless transmission between any two devices, right? So number of research is going on for different type of standards, right? So like suppose if you are from electronics background, you will be working more on these technologies, right? So you always try to make it more efficient in order to achieve better security or energy consumption, right? So number of work are going on in this particular field. Okay, the last layer is the application layer, so which provides support for business services and different kinds of personalized services to individual user. So whenever it comes to the end user, and if I want to provide some specific type of services, there will be the role of application layer. So using the application layer interface, user can access the IoT via personal computers, mobile devices such as a smartphone and tablets. So as you can see, you can control the smart home devices or all IoT devices through your computer or the mobile or a smartphone, right? So this is the role of application layer. So we will be able to provide number of schemes, a number of protocols through which any mobile device can be able to provide number of services access to end users. Okay. So apart of this, again, you can see another possible IoT standards, right? As you can see, the first layer is called physical layer. Another layer is called a combination of network and transport layer. And the third layer is known as application and messaging layer, right? So in different resources, you will be able to see different architecture of the IoT system, right? So you don't need to worry about it. It's all about which particular resource you're going to follow and when exactly it was there. So we need to consider some IoT standards that is being followed by most of the research groups. So depending on the resource, you might see different type of architectures. So this is the only reason I have shown two alternative architecture of the same IoT systems, and these are some of the protocol that can be there in any specific layer, right? So as you can see, there will be some specific role for each and every layer, and as you can see, the authentication and key management is important whenever we are talking about the security. So as you can see, the authentication and the key management is required either or in physical layer, network layer, as well as application layer. So whenever we are dealing with security, number of security mechanisms are supposed to be there, right, in order to secure our IoT system, right? And as you can see, there is one more term, that is what LPWAN, right? So LPWAN stands for low power wide area network, right? So it is one of the network that is being used in case of IoT system, right? So LPWAN allows for a long range communication of of things in IoT. So in that case, we will be able to achieve long range communication with less energy consumption, right? And again, there is a protocol that can be used in this particular layer, right? And this particular where is it? Okay, here it is. The protocol that is mainly used in LPWAN is called LoRaWAN, right? And it is mainly used for communication between gateways and end devices. So it will be able to connect your IoT system with the rest of the cloud. Thank you. Then application domain. So then number of fields where IoT can be used: the home automation, medical field, industrial control, smart cities, security and emergencies, smart agriculture, natural disaster management with IoT. So then number of application domains where IoT can be deployed. So this presentation considers some of the IoT applications domain that have emerged in recent years. So these are some important application domains where you can start with. Okay, so as shown in the figure, it focuses, as shown in the slide, right? So it focuses mainly on some of the domains that have greatly potential for exponential growth in industrial. Just give me a minute. Okay, sorry for the interference. Okay, so let's take some examples, right? Home automation. So in smart homes, various sensors are deployed which provide intelligent and automated services to the user, right? So in that case, as you can see, a smart home is also one of the most popular example of IoT, right? So they help in energy conservation by turning off lights and electronic gadgets automatically. Suppose if whenever you enter in the room, right, so the lights will turn on automatically, and whenever you leave the room, it will be turned off automatically. So in that case, you will be able to conserve energy, right? Suppose if I say, if I'm using AC, and suppose if you are not there for another 30 minutes, so the AC will remain on, right? So what happens? Suppose if I'm using the idea of a smart home concept, in that case, we will be able to tube some sensor that will be able to access, or that will be able to detect any kind of human activity. So whenever the human is present in the same room, the AC will remain on, right? And whenever someone leaves the room, and if he is not coming back for another 10 or 15 minutes, it will go to the sleep mode automatically, right? So as you can see, all the devices or all the appliances will be able to operate in an efficient way, right? So this is how we will be able to and conserve lots of energy by using the idea of, by getting the by using the technology provided by IoT system. Okay, so in most of the cases, motion sensors will be used, right? And motion sensors are the type of sensor those will be able to detect any kind of motion related activity of any user. Okay, so whenever you are going to some like parking lot, right? So nowadays they are equipped with some smart bulb. So whenever is motion sensor detecting any human activity, the bulb will be automatically on. But suppose at the night, and if the crowd is very less, there will be very less chance of human activity, right? So at that time the bulb will remain off, and it will not be depending on the manual functionalities what manual what functionalities of all these devices, right? So all these devices will be able to work automatically without having any human intervention. Apart of this, there are a number of fields where IoT can be used. So I will not go into detail. Okay, so as per your interest, or as per your research area, or as per your compatibility where you're currently working on, you get more and more information of different type of applications. So even different application, there will be some specific type of requirement, or specific type of services you are willing to achieve. So depending on the requirement of services, right, you can choose that particular field. Okay. Again, as you can see, the number of like application and market. So variable, right? Nowadays, as you can see, you can use some variable watches, right, to get different type of that can track your fitness related activity, right? So there is a possibility where we can build a home automation, okay, smart cities, automotives, right, for self-driving car, healthcare. Suppose as you can see, there is a shortage of doctors in most of the hospitals in India. So what we can do, we can provide some smart remote monitoring system that will keep detecting and that will keep monitoring the current situation of the patient, and whenever it reaches the critical condition, it will leave some emergency signal to the hospital, right? So in that case, the doctor does not need to visit as long as there is no such emergency, right? So this is how we will be able to use our IoT system to provide better healthcare system, right? So again, there's another field where IoT is being used in a very better way, smart manufacturing. As you can see, there is shortage of manpower, and whenever we talk about manpower, everything will be done manually, right? And whenever we talk about manual manufacturing, it is going to take lots of time, and each and every time, all the employees are supposed to go through the training process. But suppose if you are able to deploy some IoT or smart manufacturing devices, the same task can be completed without any human intervention. Okay, so there are number of application domains in that is being used, right, for different domains. Okay, in different types of networks. And this particular okay, then moving on. So in general, an IoT process can be considered as a 5-phase sequence, from data collection to data delivery to the end user, right? So as you can see, there are 5 different phases of IoT, starting from data collection to data delivery to the end user. So the given table demonstrates the variety of attacks categorized for 5 phases of IoT. So as you can see, in different phases, there are different type of attacks that you have to uh, that you have to face with. Okay, so data perception, storage, intelligence processing, data transmission, and end-to-end delivery, right? So this is, as you can see, then number of what phases: data perceptron, storage, intelligence processing, data transmission, and end-to-end delivery. And these are the type of threats that we have to face. Okay, and this also shows what will the type of attack we have to go with, to face with, right? So data leakage or breach, data sovereignty, data loss, data authentication can be the part of data perceptron. Whenever we are collecting data through some sensors, and whenever it is stored in some particular memory, there is a possibility of attack on availability, access control, integrity, denial of service, impersonation. So there is a possibility where some attacker will keep attacking your device or the memory device to access all this data, right? So there is a possibility where it can still make it corrupt, right? So in that case, whenever the data is corrupted, your system will not be able to work in a better way, right? So in that case, your IoT system will not be able to operate in the same way. Okay, so intelligent processing, attack on authentication, there is a possibility some unauthorized access can be possible, right? So each and every time, as you can see in different phases, we need to provide number of schemes for secure or protecting our IoT system. Okay, so this is all about different attacks that we can face at different stages of IoT process. Okay, so again, this diagram shows security threats, right? So in this case, as you can see, security threats can be categorized as cyber or physical. So it could be so no, again, as you can see, different type of attacks are being shown in this figure, right? So potential new attacks by exploiting, potential attacks at cloud services, potential attack at network services. So as you can see, the number of components are there, and we have to go through number of steps for achieving our final possibility. So as you can see, at different stages of the processing, we may face different type of challenges related to security, right? We may have to face different type of threats at different points of processing of IoT system, right? So as you can see, there is a possibility where we are connecting or sending a data through some wireless medium, or if we are using some network devices for connecting our system to the rest of the cloud, we may face some network service related attacks, right? And whenever we are at the cloud system where we are currently processing on the connected data, again, some kind of a test can be made. Okay, so there is another possibility where we can some tests can be made, can be attempted at the time of collecting these data. So there is a possibility where malfunctioning can be there, and some attacks can be there, can be made just to disable that particular type of sensor. So whenever a sensor is not working in a better way, it means we will not be able to collect all these data correctly, right? So there might be some attacks that can be only for making our system inaccurate. So in that case, suppose if we have deployed 1,000 number of sensors, and based after tracking the system, if 30% of the systems are not working right out there, it means the accuracy will be decreased by 30%. And there is also a possibility where the functionality of these sensors can be altered, even though they are still working, but the collected data of whatever type of information is being collected will be inaccurate. So depend if the data collected is data, it means the remaining process will also be affected. So IoT system will not be able to provide the specific type of service in a better way or accurately, right? So in that case, the attacker only wants our system to be malfunction. Okay, so different type of attacks can be made at different phases. Okay, at different stages. Okay, after which security threats can be categorized as cyber physical. So cyber threats can be further classified as passive or active, right? So let's start with cyber threat. So as I already told, it can be further categorized as passive or active threat. So a passive threat is a part of cyber threat. So by eavesdropping, an attacker can collect information from sensors, track the sensor holders or both. So there is a possibility it can get the control of the sensor, right? By making some passive kind of threats that is the part of cyber threat. Currently, collecting valuable personal information, particularly personal health data, has become rampant on black market. So as you can see, number of data are being sold right in the black market, and all these are some of the genuine collected data by number of manufacturers. So as you can see, someone was able to access the collected data by any industry. So nowadays, you're like some any kind of data are available in the black market, right? Suppose if I say you can look for, you can also buy data related to your credit card details. Someone can collect your data for your personal health related data. So all kind of data are available in the black market that can be used for some further uh, uh, some inappropriate thing. Okay, so the another type of cyber threat is called active threats. So in active threats, the attacker is not only skillful in eavesdropping on communication channels, but it also can modify IoT system to change configuration, control communication, and so on. So in that case, what happens? The attacker will be able to malfunction your current IoT system. So whatever type of data is collecting is okay, right? But the functionality will be malfunction. So in that case, what will happen? It will not be able to operate the entire system in a better way, accurately. So even though IoT is working, but you are not getting the correct result. Okay, so it is just creating it. It is just changing your output with some with inaccurate. It is just changing your outcome with some inaccurate outputs, right? So it will be what creating some negative image of your particular industry. Okay, the next type of attack is called physical threats. Okay, the first one is cyber threat, right? So in that case, there will be two possibilities: either some person or attacker will be able to collect your collected data, okay, access your collected data. Otherwise, it can also malfunction your system, right? So where it will and at that time it is not mainly looking for your data or accessing your data, but it is just making it inaccurate, right? The other type of threat is called physical attack, a physical threat. So in these threats, the attacker generally does not have technical capabilities to conduct a cyber attack, so it is not going to be very skillful, right? And it is not be able to access your data, or it will not be able to make any changes in your existing working system. But there is a possibility where the attacker can only affect the reachable physical objects. So it will damage your sensor, it will damage your connectivity, it will be able to damage some of the components of the IoT system, so that you will not be able to collect all the system, or you will not be able to collect data from all reachable target regions. Okay, so some of the regions will be unreachable now, since those sensors are not able to connect to the rest of the system. Okay, so the physical threats is still possible, right? If you can send someone to just destroy some of the sensors or communication links. Okay, so these are the two type threats: cyber threat or physical threats, depending on the type of attempts. Okay, moving on. So here is the categorization of security issues that we should know about, or that we should concern about, and it has been categorized into three levels: low level, intermediate level, and high level. Okay, so this table shows the taxonomy of security issues for IoT system, right? And the security threats are characterized with respect to the IoT deployment architecture. And as you can see, it can be divided into three levels: low level security issues, intermediate level security issues, and high level security issues. Okay, I will not be going into very detail, right, of all these type of issues, but as you can see, number of challenges can be faced at different stages of the network. Okay, so I will give a very brief idea, right? What kind of I will just give a brief idea for low level security issues, and based on this you can see what kind of issues or what kind of challenges you might have to face with other levels. Okay, so let's start with low level security issues. So the first one is jamming adversaries. So jamming attacks on wireless devices by emitting radio frequency signals without following a specific protocol, right? So in that case, it will be able to impact the network operations and can affect the sending and receiving of data. So as you can see, whenever you are collecting data, it should also be sent transmitted to the rest of the devices, right? So in that case, it will be able to it can affect the sending and receiving of data with these devices, right? So resulting, it will be able to malfunctioning or unpredictable behavior of the system. So the malfunctioning or unpredictable behavior of the system is possible, right? The another possibility is what? Insecure initialization. So a secure mechanism of initializing and configuring IoT at the physical layer ensures the proper functionality of the entire system, right? Without violating privacy and disruption of the network system. The physical layer communication also needs to be secured in order to make inaccessible to unauthorized receiver. So in that case, we have to come up with some very good technology or some scheme so that no unauthorized user or no authorized person will be able to receive all these systems or data, right? So we need to provide different level of security to different type of users, okay, at the physical layer. Low level Sybil and spoofing attacks. So there is another category of kind of attack. So the Sybil attacks in a wireless networks are caused by malicious Sybil nodes, which use fake identities to degrade the IoT functionalities. So what we can do, suppose if we have already 1,000 number of nodes within the target region. So someone will be able to include 100 more sensors with the same in the same IoT system, and they will come up with some false identity, but they will again be the part of they somehow they will become the part of the IoT system. So as you can see, initially we had only 100 number of 1,000 number of systems nodes, right? But now we will be having 1,100 systems, and we will keep collecting data from all these sensors. Those because those have become also the part of the same IoT system, but the data collected by all these nodes are not accurate, and again you may face a problem of inaccurate or unpredictable behavior of the IoT system, right? Just like that, there are number of type of different effects, and this particular diagram shows the implication of these type of security threat, right? So as you can see, in first case, it can cause an issue of disruption and denial of service. The insecure installation can cause a problem of network disruption and denial of service. Just like that, different type of issues might affect the system by different way, right? So insecure physical interface can create an issue of privacy isolation, privacy violation, and denial of service, right? And sleep deprivation. This is again one of the very tricky attack, right? So the energy constrained devices in IoT are vulnerable to sleep deprivation. If you remember, I already told all these devices will be able to operate automatically. So whenever they are not in use, it means they can go to sleep. But suppose if any attack is going to be made that can keep all the system always in the active mode, it means the energy will be consumed, right? So in that case, even they are not in use, they will still be in the active mode, right? So in that case, they will also die very soon, right? So energy sleep deprivation attack can be made if some of the devices those are supposed to be in sleep mode are still in active mode by making some attempt. They will never be allowed to go to sleep mode again. Okay, so energy in that case, lots of energy consumption will be, and the IoT will not be able to achieve this particular uh, objective, right? Where energy consumption should be as minimum as possible. So after which, these are intimate level security issues again, and this figure shows the implications of these issues at different aspects in different aspects. Again, high level security issues, again as you can see, the implication of issues are being shown in this figure, and depend, like you may face different type of problems if such threats are being made. Okay, so I hope there should not be any doubt. I have already mentioned some of the issues related to low level security issues. Okay, and I have also discussed the implications of these issues for the existing IoT system. Just like that, you can consider some other type of issues at different levels of the IoT system. Okay, and these kind of threats can be made at different layers of the IoT system. Some of the attacks can be made in the physical layer, some of the attacks can be made in the network layer, and some of the attacks can be made in the application layer. And depending on the type of attack, we may consider different type of we can categorize as different level of security issues. Okay, so due to which it has been categorized into 3: low, mid, intermediate, and high level security issues. The next thing is security requirements. Okay, uh, just give me a minute. Okay, any doubts so far? Please let me know if you have any doubt.
No, sir, no doubt.
So moving on, the next thing is security requirements. Security requirements, which are essentially the basic of measuring security. can be defined as a set of conditions that describe properties of IoT security cores, right? So it can be defined as a set of conditions that describe properties of IoT security cores. Okay. So security goals such as confidentiality, integrity, availability, non-repetitions are considered as properties to achieve security objectives. So these are some security goals those are supposed to be achieved. Okay. So these are nothing but the confidentiality, integrity, availability, and non-repetition or non-repetition. So all these objectives are supposed to be achieved whenever we are talking about IoT security related goals. Okay. So there exist different security issues to be addressed within the three layer of the IoT architecture. So as you can see, you have seen two different IoT architecture. The very common one is called three-layer architecture, where we will be having only three layer: physical layer, network layer, and application layer. Right? Not physical layer, it will be known as perceptron layer. Okay. So the perceptron layer, I have already discussed the basic idea of perceptron and other layers, right? So the perceptron layer, the perception layer is not perceptron. Sorry about it. It is supposed to be called perception layer only. Okay, perceptron is one of the terms used in AI. Okay. So perception layer is vulnerable to several physical attacks, such as malicious tampering of end devices and their communication links and denial of service attacks. So these kind of attacks can be made at perception layer. The network layer is exposed to several threats found in traditional computer network, and moreover, it also has some vulnerabilities that are specific to the IoT, including network protocol issues, privacy disclosure, and compatibility issues. So number of challenges, a number of attacks can be made even in network layer, right? It can be related to protocols or some privacy or compatibility, right? So in that case, again, there is a possibility of uh, unpredictable performance of our operation of all these internet devices. The application layer also has some vulnerability issues such as data access, security authentications, and malware. So when application layer is responsible for playing different for a specific type of roles, and whenever we are at the application layer, we will be mostly dealing with data. So whenever we are in the application layer, some attacks can be made to unauthorized access in the data. And whenever some attacker is able to access our data, it will be able to either it will be able to steal this data or it will be able to alter the data, right, to make it inaccurate. Okay, there is another possibility: malware can be attacked. Malware can be there so that all the entire system will stop working. It will not be able to work in a better way, accurately. So malware kind of attack can also be made in application layer. So different layers, different type of attacks can be made. Okay, and we have to face with different type of security issues within these three layers. Then some of the security requirements that we should consider. Generally, the primary goals of the network security can be categorized in three different terms: confidentiality, integrity, and availability. Later on, security properties have been broadened over time to include other security properties. Later on, number of security requirements were added along with existing IoT system. So here is the list of security requirements that we should consider at the time of developing any IoT system. I will give a very brief idea of all these security requirements one by one. So let's start with confidentiality. The confidentiality is the property that ensures that information is not disclosed or made available to any unauthorized entity. So any unauthorized person will not be able to access any data. Okay. Integrity. It is the property of safeguarding the correctness and completeness of asset in IoT system to protect sensitive locally stored data such as personal user data like credit card numbers and medical records, right? So in that case, no personal level information should be shared with any unauthorized access, right? And we also need to secure all these data in order to make it in order to in order to maintain the correctness and completeness of the IoT system, right? So if you are able to secure all personal related data, right, our system will be able to perform correct, and it will also be able to achieve all complete objectives mentioned by the developer. The next thing is availability. So availability refers to the property which ensures that an IoT system, a system is accessible by authorized entities all the time. So in that case, what happens, as you remember, if you're an end user, if you're a developer, and if you're some other type of developer, right, different access level can be provided. So in that case, as you can see, different level of access can be provided to different type of users. If you're an end user, you will only be able to access your personal related information. If you're a main developer, you will be able to access the data of any end user. And if you're an intermediate developer, you will be able to access only limited level of data, right? So depending on the accessibility, depending on the level of accessibility, the data, the availability of data can be different. Then another is authenticity. So authenticity is the assurance that information transition is from the source it claimed to be the form. Okay, so in that case, as you can see, authenticity is also important. Another thing is authorization. So a property that determines whether the user or device has rights, privilege to access a resource or issues commands. So in that case, what happens? Suppose if you're an end user, so you will only be able to access your personal related information, right? So you can check how many meals you have covered, how many distance you have covered, how many steps you have made. But suppose if you're a developer, you will be able to make a comparison of all these collected data, right? So different level, different type of users will be able to get different level of authorization to the functionality, okay, other data. Another thing is non-repetition. So it is also known as NR. So NR is the security property that ensures that the transfer of messages or credential between two IoT entities is undeniable. So in that case, we will be able to achieve end-to-end transmission between any two end devices. Those are the part of IoT system, right? And the transmission should always be undeniable, right? So we have to make it sure, okay, by using this, by achieving this particular requirement, this particular goal. Then accountability. What is accountability now? It is nothing but the property that ensures that every action can be traced back to a single user or device. So in that case, as you can see, if any action has been taken, so we will be able to trace all previous actions related to that one. Okay, so in that case, so that whenever we are able to trace all the functionalities, all the processing, we will be able to make some and device or any particular user accountable for that. Okay, so the tracing of any steps or any processing is also important. Another is reliability. The next is reliability, and it refers to the property that guarantees consistent intended behavior of IoT system. It means it will be able to achieve all possible activities, or it will be able to perform all transmission of data reliable way. Right? In that case, there will be very less chance of packet loss. There will be very less chance of data loss. So whenever we are able to achieve all these schemes, or whenever we are able to involve all such schemes, reliability can be maximized. Okay, privacy. So I'm not going to discuss more about privacy since it is a very standard term. Okay, then physical security. It means we also need to provide some physical type of security to all IoT devices so that no unauthorized person will be able to attack physically any one of these systems. So some of these IoT systems can be protected from some guarded system, right? Okay, we can provide some fencing to some tower with transmitter, some kind of like security can be provided to all these physical devices. So these are the main security requirements at the time of developing any IoT system. Okay, moving on. Security mechanisms to achieve security requirements. So again, so these are some of the mechanisms that we can use or that we can consider for achieving all these security requirements. The first one is authentication. It is nothing but the security service that verifies the identity of user or device. So in that case, we have to identify whether he's an authorized one or not, right? So authentication is required so that only authorized person will be able to access our IoT system as well as the data. Then access control. So access control refers to the security mechanism that limits the actions or operation of a legitimate user or device in a IoT system, right? So access control is also required because it is very similar to that. So if it's willing to send some data, right, through the medium, so we need to make a decision whether that particular device or whether that particular person is allowed to access the link or not, or is allowed to send any information or not. So before that, it has to be authenticated first. Okay. Then encryption, again, encryption is very important whenever there is an end-to-end transmission between any two end users. And to protect our data, we can use some encryption type of technologies so that it can, even if it is accessed by some user, it will not be readable. Okay. And it can be decoded only by using either public or private key. Secure booting is possible because whenever we are having any problem, right, so we can go back to a stage where we can boot up our system again, right, and it should all be the secure booting. It means no unauthorized person should be allowed to malfunction our system, and no authorized function should be allowed to start rebooting process. Okay, so nowadays you might have seen in Hollywood movies, right, where any unauthorized person or attacker can reboot some entire plant, right, or entire unit, right. So such facility should also be provided. Such security mechanisms should also be provided. Then secure update. So secure update is very important because, as you know, depending on the requirements, you have to make some updates with the existing IoT system. So no authorized person should be able to update by his own side. So in that case, before updating a system, we have to check whether it is being made by the secured person or not, authorized person or not, right? So if it is not, if it is made by the unauthorized person, it means he can include his own personal information, or just like just malware. It can also make an attempt like a malware attack, right? So that can make it unpredictable and inaccurate. Okay. Backup is always there, right? So we always need to keep backing up our system or some previously collected data, right? So in that case, whenever there is a situation where we need to restart a system, we can come up with the previous backed up data. Okay. So security physical location, securing physical locations. So this is all about accessing, avoiding any physical type of attacks. So we can choose some location, or we can put all those devices in a position where no physical attempts can be made. Then device tampering detection. Okay, so it refers to the security mechanism to ensure tampering of any IoT device or network. Okay, so we need to provide all such mechanisms at different levels of the security codes. So some of the attacks can be made in the physical layer, some of the attacks can be made in the internet layer, and some of the attacks can be made in the application layer. So depending on the level of the attack, different type of mechanisms can be used. Okay. So the next thing is, so basically security requirement should be specified based on the analysis of the services and assets to be protected, right? So what kind of analysis or what kind of services and what kind of assets we are willing to protect. Okay, and this particular table provides a summary of the security requirements for 9 different application domains. So as you can see, the number of application domains where number of security mechanisms can be provided: smart home, smart grid, smart city, and so on. Okay, so before continuing from here, let me tell what these abbreviations means for. All right, so CONF stands for confidentiality, ENTG is integrity, AV avail is nothing but availability, authenticity, authorization, non-repetition, accountability, reliability, privacy, and physical security. Okay, let me repeat this again. Configuration, confidentiality, integrity, availability, authenticity, authorization, non-repetition, accountability, reliability, privacy, and physical security. So I will take only one example, right? How these mechanisms can be useful, right, in order to design any IoT system for a specific application domain. So let's take an example of smart home security requirements. Okay, so in that case, smart home will be having following security requirement should be following security requirement that should be guaranteed. Okay, so information is protected from disclosure to unauthorized individual or devices, so through which you will be able to achieve confidentiality and privacy, right, if you are able to protect the data, okay, or any personal information related to the end user. No data are modified or deleted by unauthorized person for any malicious reason. So in that case, we will be able to secure our data from any unauthorized access through malicious attacks. So in that case, we will be able to achieve integrity as well as what? Accountability. Okay. So in that case, integrity is there, where since we are able to protect our private data, and accountability is there because each and every person will be accountable for making any changes in the data. Any doubt? Can you please mute yourself? Uh, Swati. Swati, can you please mute yourself? Swati, can you hear me? Okay. So where are we? Security requirements uh, for smart home system, right? IoT system, right? So through integrity and accountability, data or any personal information cannot be modified or deleted. Okay, through which we will be able to achieve integrity and accountability. Now, only authorized person or device will be able to access any information on the network. So through which we will be able to achieve authenticity and authorization. So each and every time any person or any user is willing to access any data, right, it must go through some initial step. So in that case, the authenticity and authorization can be achieved. So authorization is there, right? And okay, authenticity can also be achieved. Okay, so in that case, authorization is there because none of your guests should be allowed to access your smart home system, right? If he's also able to access the smart home system, it means he can make any changes as per his requirement. So in that case, you are the only one who wants to get the control, has the control. So there is a possibility where we can share our security code, right? For providing such level of access. Okay, then only it will be able to access your uh, uh, smart devices. Okay. Now an attacker cannot be able to decipher any captured or snipped data. So in that case, it will not be able to access your personal level collected data. So this is how you will be able to achieve. Again, you will be able to achieve confidentiality. Okay, it means no data can be accessible by any unauthorized user. Okay, the services of the smart devices should be available to authorized entities whenever needed. So in that case, as you can see, suppose this is one of the example, right? I just told. So no guest will be able to access your smart home system. So in that case, what happens? Only accessible user, or you can see all your family members will be able to access these devices. So as you can see, all the devices are available only to your family members, right? Again, physical security can be provided. So in that case, you can deploy all these devices within your home. So no physical attacker will be able to access those devices directly. So this is how you will be able to achieve physical security for all your IoT type of devices. Okay. So this is all about security requirements and mechanisms to achieve those security requirements, right? Those might be different depending on the application domain, and different requirements and different application domain, the focus will be different, and you will be targeting a specific type of requirements to achieve or to design any IoT system, right? And depending on the requirement, you can choose any particular scheme at different level of different level of uh, security, right? So this is how this the figure shows what the total number of publications over time. Okay, and as you can see, number of papers are being published in the field of healthcare area. Number of papers are being published to design or modifying some existing routing protocols or different type of protocols to make it more accurate, right, in terms of functionalities. So these are some of the sectors where IoT system number of work is going on, research work is going on. A lot of research work is going on in health sector. Lot of research work is going on is in health agriculture sector. And as you can see, number of papers have been published in security, right? So there is a possibility where we always try to make our IoT system very as secure as possible. So number of security mechanisms can be introduced. So if you're from mathematical background, if you're very good at this particular field, right? So there is always a possibility where you can continue with. Okay. Smart cities has also become very popular in last 5-7 years. Okay, after the government has taken the initiative of smart cities, so a lot of research work is also going on in the field of smart cities. Okay, and again, as you can see, smart security can also be the part of smart city. So security can be the part of any other category or any other section, right? And these are the list of papers published in between 2013 and 2018. Okay, so depending on interest, right, and depending on the availability of resources, you can choose your field for your further research work. And this diagram shows the number of publication in IoT technologies. Okay, so as you can see, healthcare, protocols, agriculture, security, and smart cities. So these are the number of publications have been published, right? So as you can see, the number of publication are increasing exponential, right? So as you can see, a lot of research work is going on in the field of IoT system, even though they are not in the same field, right? So as you can see, the yellow one shows the number of publication in the field of security. So the total number of published papers in securities are even more, right? After which number of publications are being made in the field of protocol. Since you're from electronics background, so I think this would be the most suitable area that you can start with, right? So it totally depends on your background and your interest, right? So depending on interest, depending on compatibility, depending on expertise, you can choose any particular field for your further research work. So this figure shows a typical IoT security architecture. So I already told there are 3 layers: perception, network layer, and application layer. And different type of security mechanisms can be applied. And suppose if you're working on 3G technology, you can still provide some security mechanism to make it more secure. So each and every protocol or each and every scheme should be integrated with some security mechanism, right? So in order to protect our IoT system in somehow. Okay, so as you can see, all these layers are equipped with some security mechanisms to provide some level of security to our IoT system. Okay, so I already told there is a possibility where AI and ML can be integrated with IoT, right, in order to make it more efficient. So number of benefits are there if I try to include the idea of AI with IoT. So efficient resource utilization is possible, because in that case you will be able to use the scheme. You will use the advantages of AI to make it more to achieve better load distribution, right? So in that case, all the resources will be able to utilize in a better way. So security can also be improved. Human intervention will be minimized, because everything will be done automatically. Whenever we talk about AI, it means there is a possibility where human intervention can be minimized. So through AI, human effort can be minimized, right? Development of AI through IoT. So each and every idea, each and every scheme can be integrated with some existing schemes of AI. So there is a possibility where AI can be used to make it more improved, to make any IoT system more even better, right? In terms of accuracy, in terms of privacy, in terms of functionality. So AI can always be helpful. Okay, and it will also be able to save time, because everything will be done automatically. It means there will be very less time will be required, and there will be very less requirement of manual functionality. So time can also be saved if I'm going to apply the idea of AI, because the same idea can also be applied to some other related requirement or domain. Okay, because in AI we don't need to write the code for each and every uh, application, right? So the same idea can also be adopted for different type of schemes or different similar idea. Okay, so saving time is also possible. Okay, number of challenges. If I include the idea of AI with IoT, security is there, compatibility is there, artificial stability, lack of confidence, cloud attack, and technology. So let me discuss all these very briefly. Let's start with security. So since AI and IoT are collecting important and sensitive data from user, we must ensure the data is secure, right? So security is always the main concern with all collected data related to the end user. Okay. Compatibility and compatibility. Because of many devices connected together in IoT, they may have different technologies, right? And they might not be homogeneous in terms of functionalities or hardware support. There is a possibility where we may find some may have some difficulty after combining all these devices. So we are supposed to make it compatible so that different type of devices will be able to communicate to each other for better for transmission, data transmission, and compatibility. Okay. Then artificial stability. Sometimes we can make some stability with while applying some AI based techniques, so it is also possible. So we can be very overconfident. If I'm applying some artificial AI based scheme, it should work fine, but sometimes it might not be able to get a good result, even though there is a possibility where it can even make it worse. So artificial stability is also one of the challenges that we can face. So we are supposed to be expert, or we are supposed to be very good at that field before applying any artificial intelligence based scheme or techniques along with IoT system. Lack of confidence is there. As we know, IoT is latest emerging technology. That's why both consumers and business have a serious concern about the security and have little confidence about to protect IoT devices. So there is a possibility where we can still not be very sure, right? So even the user or the developer does not really know, like at what level it will be able to protect our system, right? So in that case, lack of confidence is still the challenge. It means we keep working in this particular field to make it even more secure for upcoming security breaches. Okay, then cloud attacks is still possible. So the rapid growth of cloud computing technologies has attracted unwanted attention from harmful virus. So any cloud system can also be attacked by some virus. So we need to provide some level of security through firewall or some other scheme, right? So that a cloud system can still be secured by any such attacks. Okay, technology. So as you can see, with time the technology is also changing, so we have to come up with some idea so that it can be made, we can make our IoT system or any security system futuristic. So whatever objective we are able to achieve at this moment should also be there for coming 5 to 10 years, right, after making minor changes. So we have to come up with some technology scheme that could also be considered as futuristic. Okay. So there are also some drawbacks or disadvantages if I'm going to integrate the idea of AI with IoT. So some of these are like that. Some of these are as follows. Security and privacy can be greatly compromised. There is a possibility. Okay. Excess power consumptions and energy uses. Suppose if I'm not going to implement any AI based technique in a very carefully, it may cause a problem of energy consumption. So in that case, even though it is not working very correctly, or even though it is not able to protect our system in a better way, but it will take lots of processing and processing and power energy, right, for computation purpose. So in that case, we have to sacrifice, or we have to compromise with energy or battery uses. Okay. So in that case, even though security is very important, we will not be allowed to use any very high-tech AI-based scheme. So we have to come up with some idea that is secure as well as energy efficient. Okay. Unemployment of manual staff. If I'm going to adopt the idea of AI, it means there might be problem of unemployment. Okay, and many like workers may lose their job. Complexity is there. It will make the system very complex if I'm going to include number of schemes together. Internet bandwidth, it means there is a possibility some more data, some other type of information might be exchanged between any two devices. Suppose if I say if I'm going to achieve security, there might be some possibility where we will be using the same link. for exchanging our public private key or some other security information. It means we also had to compromise with the available bandwidth. So some of the data, some of the bandwidth that was mainly available for transmitting data will also be used by some other type of information that is not the actual data. Lack of flexibility and interpretability. So there is a possibility flexibility can be minimized. Okay, can be compromised. So even though after applying some specific kind of scheme, it may not be flexible for some other application domain. So as you can see, by integrating the idea of AI within IoT, there are the number of benefits we can get, right? After which we also need to consider some of the challenges we can face. If I include the idea of AI with IoT, and then there also be some disadvantages that these are not the exactly disadvantages. These are always the concern that we need to keep in our mind at the time of coming up with some ideas. Okay, that sometimes it can make our system very effective. At the same time, it can also make it even worse. Okay, so these are some of the disadvantages if I try to include the idea of AI without any research or without having any expertise in this particular field. Okay, that's it. So that's it with me. Okay, so if you have any doubt, you can ask. Vishnu sir, your queries are welcome. Anyone having any doubt related to this presentation or related to this?
Participants can ask your queries.
There's no doubt then. Okay.
Anyone?
Okay, sir. I don't think there is
Yes,
any
sir.
doubt.
I think, sir, there is no doubt
Yes, sir.
from the participant side.
I
Okay,
hope you
sir.
like the lecture.
Sir. Yes, sir.
There was a query, sir. Is there any
Okay.
security protocol used specially for IoT applications in spite of network security? There is no specific security protocol that can be used at any place, right? So it totally depends at which protocol layer you are working on. If you're working on 3G, if you're working in the application layer, or if you're working on any specific kind of technology, you have to come up with that particular protocol. So not the same protocol can be used for achieving all possible objectives. Partha, I hope you got the answer.
Okay, sir. I think that there is no query by any participant. Yes, sir. So I would like to thank you, sir, and we sincerely appreciate you for taking out time from your busy schedule to provide us with such a valuable information. So I wish you a great luck with all your future projects, sir. So thank you, sir. Thank you so much for being with us.
Thank you so much, sir, for considering me.
So the message for participants that at 3 p.m. There is a validity session. So validity session will be of around 20 minutes. After that, we will share the link for the test. So see you soon. Thanks.